Okay, Assalamualaikum, everyone. So today we are going to do some revision about the AC and DC circuit. So normally in a DC circuit, so you are going to look in terms of this format, which is when we try to represent the voltage. Normally we are going to use these symbols, okay, either cell symbols or it could be in the other way around, which is we use the circle and we have the notations plus and minus there. Now it's going to be the same thing, which is for the AC. So we are going to have this kind of symbol for AC. But normally in terms of the AC and DC, the most particular forms that it's going to be in difference symbol just about the voltage. Now, how about the in terms of the impedance? Of course, let's say before this for AC, sorry, for DC, normally we are going to have a purely resistive in the circuit. Now, when we are considering in terms of the AC, so we are going to have the imaginary, which is going to be uh, X. Okay, so this X, it could be referred to XC, which is normally is referred to capacitance. If we say it's referred to XL, normally is referred to the uh, inductance. Okay, so what is the formula for Xc? So the formula for Xc is Xc is equal to 1 over J omega C, right? So if we transform here, so what is omega? Omega here is 2 pi f, so which is f here is referred to the uh, frequency. So normally in Malaysia we are using 50 hertz. If in such a country, some of them use 60 hertz. So it depends on the country. Okay, but in our situation, if it's not mentioned, then we are going to refer to our frequency here is going to refer to 50 hertz. Okay. Okay. Now, in terms of Xc, so if we put all the values here, so then we are going to obtain Xc. But of course, if we try to change the conjugate here from bottom to top, then we are going to obtain, it's going to be the same particular form, so which is Xc is equal to uh, minus J over omega C. Okay. So of course, we are going to put J here. Now it's going to be the same thing. What is XL? So XL normally is happen for J omega L, right? So which is referred to omega L. Okay. So it's just a straightforward. If we put here, so that's why normally when we have inductive, normally we are going to have in terms of the positive J. If we have Xc, normally we're going to have negative J. Okay, based on this formula. Okay, now let's we see one simple circuit. So what is going to happen when we have this kind of circuit? Okay, so I just cancel some of it. We try to look one simple examples here. Okay, now just choose another pen here. Okay, now let's we consider we have this kind of circuit. So now what happen if we try to connect in terms of the um what we say voltage in terms of the DC voltage, we connected with the resistance and also we connected with the inductance. What is going to happen? Okay, so now based on this, so we are going to find what is the value for XL here, right? So now if we go back to our formula here, XL is equivalent to omega L, so which is 2 pi f times L. Now what is the value for f here for DC? So DC is a constant, so it means the frequency for DC is going to be 0 hertz, right? So when we have a 0 hertz here, then 2 pi times 0 L, whatever the values of L here. So of course, everything is going to be 0. Now, what is significant when we have a 0 XL here? So when we have a 0 XL here, normally it's just about the short circuit, right? So it means that uh, for DC, okay, so if we have inductance, so it's going to be represented in terms of short circuit. Why? Because the XL here is 0. Now, what happens if we try to replace this L with C? Okay. Sorry, we are going to draw quite similar diagrams here, but now instead of we have inductance, we change with the capacitance. Okay. So the rest is going to be the same. Now, what is the value for HC here? Okay. So of course we said okay, HC is about omega C. Now we have 2 pi f times C, and as we explained on the top here, the frequency for DC is 0. So we are going to write here 1 over 2 pi 0 times C, right? So, and of course it's going to be 1 over 0. When 1 over 0 is going to be infinite. So it's mean for HC, okay, the uh the impedance here is going to be infinite. So which is of course if we uh, notice when we have a very big impedance here or admittance here, so it just look like the open circuit. So as a conclusion, so we can say for DC, if we have a capacitance, normally it's going to look in terms of the open circuit. Okay, so this is some of the basic understanding that you should know, and you need to learn carefully when we are dealing with the passive components such as capacitance and also inductance. Okay, so this is how you need to be careful. So if the circuit is DC, then what happened to the inductance is going to be short circuit. So if you have the capacitance, now the circuit is going to be the capacitance part is going to be open circuit, right? So I think this is a very quick the revisions about the basic concept of the AC and DC. So hopefully you get some point here how to solve your assignment and also the questions related with the final exams. Yeah, I think that's it for this short explanation. Please try your best to answer your assignment. Good luck.